Hello students, in this video lecture class, we will discuss testing of an alternator. Two type of tests can be performed with alternator, open circuit test and short circuit test, which is covered in your syllabus. After completion of this topic, you will able to perform open circuit and short circuit test of an alternator, and also it helps to determine the voltage regulation. So, what is the purpose of testing of alternator? Open circuit test, the definition is that open circuit test and short circuit test are performed to find the synchronous impedance of an alternator to determine voltage regulation. So, let us first start open circuit test of an alternator. Here I have drawn the circuit diagram for performing the open circuit test. In this diagram, you have seen that the field winding is in series with the variable rheostat. Here what is the purpose of adding rheostat to the field circuit? To vary the field current, and field is excited by giving DC supply, and armature winding, that is the stationary part of an alternator, is kept open. It means no load is connected across the armature winding, and the alternator is run at a synchronous speed. At starting, you keep this rheostat at its minimum position. It means no current is flowing through this field winding. Gradually, if you increase the rheostat, field current also increases. Here, if you see the armature winding, I have connected one voltmeter across the terminal L1 and L2. It means the voltage between any two terminal gives the line quantity. Here I have only connected one voltmeter. My motto is to measure this voltage, means voltage in between line L1 and L2. As the circuit is balanced here, so no need to connect the 3 voltmeter across any two terminal. Here only I choose one pair of terminals L1 and L2 and connect a voltmeter across this terminal. Now, if you increase this rheostat, at starting it is in minimum position, so field current is also 0 and terminal voltage across the armature winding is also 0. But if you increase the rheostat, gradually the field current also increases and voltage read also increases. Now, you increase the rheostat in such a way that with increase in field current up to some extent, the voltmeter it gives just above the rated voltage of an alternator, and that value you have to note down, and that value is the open circuit voltage. As here the circuit is open, means armature circuit is open and no load is connected across the armature winding, hence the terminal voltage of an, that is the EMF induced in an alternator in between any two terminal are equal to the terminal voltage of an alternator. To get the EMF generated, open circuit EMF generated per phase, open circuit EMF generated per phase, that is E0 is equal to whatever the voltmeter rating just above the rated value of an alternator you get, you divide that quantity with root 3. Suppose this reads a voltage of V volts, This is the line quantity. To get open circuit EMF generated per phase, you divide that quantity with root 3. Okay, now after getting this value, you will draw the E0, that is open circuit voltage per phase, and field current, and study their characteristics curve. Here I drew the nature of the curve E0 and E0 versus IF curve. It means it shows with increase in current how the open circuit voltage per phase increases. The nature of the curve is like a magnetization curve. It increases up to some value. After reaching its rated value, it comes to saturation. It saturates. Okay. And this, if I extend this straight line portion, it is called as air gap characteristics. This is the air gap line or air gap characteristics. This curve shows the open circuit characteristics of an alternator. Okay. The short circuit test of an alternator. This diagram, this arrangement, it shows the short circuit test of alternator. Here in this diagram, see that the armature winding, it is short circuited. Okay, all the three phases are shorted. Since the three currents will be equal, and here my choice is a balanced system. All the three phases are balanced. What do you mean by balanced system? Balanced system means all the line and phase quantities are equal. So here, since all my three currents will be equal, only one ammeter is connected in any one of the three phase. A high rheostat is connected in the DC field. This is the rheostat. Okay. A high rheostat, high value of rheostat is connected in the DC field circuit to vary the field current. The machine is run at synchronous speed. The field is excited by giving a DC supply. Here you excite the field or raise the value of its current by varying this rheostat from 0 to 150 to 200% of full load current. And the reading of here also you connect one ammeter. On the first case also, on the first case means for drawing this open circuit characteristics also you have to connect one ammeter here to measure the field current. In short circuit test also you connect one ammeter here, okay, to read the field current. So in this case, gradually if you increase the rheostat, you have to measure this two current. This ammeter, it measures the field current, and this ammeter, it measures the armature current. And the reading of two ammeter gives field and armature circuit current. And the short circuit characteristics can be drawn by plotting the curve between the short circuit current and field current, which is normally a straight line through the origin. Clear? So now I draw here the curve between short circuit current and field current on the same open circuit characteristics curve. And the nature of the curve is almost straight line. Almost it is a straight line. This is the short circuit characteristics. And why? My motto is to draw these two characteristics curve, means open and short, in this single diagram to find the synchronous impedance. So up to this topic, students, you have learned how to perform open circuit and short circuit test of an alternator. Next we discuss how to calculate synchronous impedance. Let us discuss how to find synchronous impedance from the open circuit and short circuit characteristics curve. Synchronous impedance, that is ZS, it can be determined from the short circuit current corresponding to field current, which gives the EMF generated per phase in the armature winding. Okay, see, open circuit test, it is the curve between armature generated EMF per phase and field current. Short circuit characteristics, it gives the relationship between short circuit current and this field current. And synchronous impedance, it can be determined from this curve. From this curve means from short circuit current corresponding to field current, which gives the rated value of EMF generated. So here, this is the, suppose this point which is just before saturation, it is the rated value of armature EMF generated. Here, this OA point is the field current, which gives EMF generated per phase, rated value of EMF generated per phase, that is AC, and the short circuit current AB. So how you write the value of ZS here? The value of, see, as my circuit is open circuit, means if my circuit is, which circuit? Armature winding, it is open circuited. So the terminal voltage is equal to the generated EMF per phase, which is equal to the short circuit current into the impedance, okay. And from where I get this equation? From this. As ZS is, let us describe how we find this equation. As, see, as ZS is open circuit voltage per phase, ZS means impedance, voltage by current, that is from this curve, ZS is AC by AB. AC by AB, that is open circuit EMF generated by short circuit current. Hence the definition of synchronous impedance. Hence the definition of synchronous impedance is that it is the short circuit current corresponding to field current that gives the rated terminal voltage per phase, Okay, the open circuit voltage divided by the short circuit current corresponding to field current gives the value of ZS. Since on short circuit, during short circuit the terminal voltage is 0. If you remember the circuit diagram, and under the induced, again I draw the short circuit diagram here for your better understanding. If you remember that circuit diagram, this is the field winding. I do not connect here, as you know that rheostat is connected, no need to again draw the circuit. During the short circuit condition, the whole of this is the terminals of the armature winding. These three terminals are shorted, so the voltage, induced voltage is 0 here. Okay, so whole of the induced EMF is utilized, whole of the induced EMF where in this winding is utilized to create the short circuit current. Hence E0 is equal to, hence E0 is equal to ISC into ZS. Clear? And from this relation, ZS is equal to this open circuit EMF generated per the short circuit current. Okay. So, ZS is equal to E0 by ISC. ZS is equal to E0 by short circuit current. And you will use this formula in any of the numerical to find ZS value. And from this relation, as you know that the synchronous reactance, it is the synchronous reactance. How you get synchronous reactance? From this equation, suppose the effective value of the armature resistance is Re. So synchronous reactance, it is equal to, as you know that ZS is equal to R square plus x square root over. From this relation you get the synchronous reactance is equal to ZS square minus R square whole root over. This is the formula for finding synchronous reactance. In general case, this effective resistance of the armature winding is very less, and on that case the synchronous reactance is equal to the synchronous impedance. So this is the total description on how to find the synchronous. The next point is short circuit ratio. Short circuit ratio. What is short circuit ratio? Short circuit ratio, it is defined as the field current to produce rated voltage to the field current to produce the rated value of short circuit current when the alternator runs at a synchronous speed. From this graph, you will calculate the short circuit ratio. Here, short circuit ratio is the field current, the value of, this is the field current, okay, this is the field current, and the rated value of voltage you get from the open circuit characteristics curve. It is the ratio of what? Field current required to give rated value of open circuit voltage to the field current to circulate the rated value of short circuit current in the short circuit characteristics or short circuit test. So suppose this is the, this IF1, it is the current, this IF1, it is the current which gives the rated value of generated EMF, and this current, it gives the rated value of short circuit current. So the short circuit ratio, it is equal to IF1 by IF2, or from this curve IF1 is OA, okay, IF1 is OA divided by IF2 is OD, or you may write in place of OA it is AB, and in place of OD it is DE, AB by DE, or D is equal to AC. So in place of DE you may write AC. So hence short circuit ratio is equal to AB by AC, or you may write this equation as 1 by AC by AB, and this AC by AB, AC by AB, AC by this one, AC, it is the field current which gives the rated value of EMF generated, okay, and this AC and AB, AC is the per unit voltage, it is called as per unit voltage on open circuit condition, per unit, this one, this range, this one, up to this is the rated value of generated in EMF. So AC, it is the per unit value on open circuit voltage, and AB, it is the corresponding value of corresponding this one up to this corresponding value of, and AB from where you get, this is the short circuit curve, from the short circuit curve you get. So AB, it is the corresponding value of short circuit current. It is clear now students? Again I repeat, AC by AB. AC from where you get? AC you get from the open circuit characteristics curve. So it is the value of per unit open circuit voltage, and AB you get from the short circuit characteristics curve. This short circuit characteristics curve, it is the per unit value of short circuit current. So AC by AB, it is the ratio between the per unit value of open circuit voltage on open circuit test to the corresponding per unit current on short circuit test, or per unit short circuit current on short circuit test. Clear? And it is equal to the synchronous reactance. It is equal to the synchronous reactance. So here from this you are very clear that short circuit ratio is equal to, therefore short circuit ratio is equal to reciprocal of synchronous reactance. From this relation it is clear. Okay, and the value of synchronous reactance, where it is depends? It depends upon the saturation condition of the machine. Okay, and a small value of SCR, SCR means the short circuit ratio. The small value of SCR indicates a smaller value of current under short circuit condition due to the large value of synchronous reactance, due to the large value of synchronous reactance. From this relation it is very clear now. If synchronous reactance is large means the short circuit current is less, per unit short circuit current is less. So what conclusion get? The small value of SCR, okay, if excess is the synchronous reactance is more, then SCR is less. So small value of SCR indicates that the value of current under short circuit, the value of current under short circuit is also small or less due to large